Hey everybody, I'm Thomas Hunter. This talk is, of course, Node, Redis, and You. If you're here for the Redis Node and You talk, it's next one over. That was a joke. All right, cool. So I work at OpenTable. We use a lot of Node. We use a lot of Redis. Quick show of hand, who uses Node in production? Cool, most of us. And then who uses Redis in production? Cool, even less. Perfect. All right, and of course, follow me on Twitter for that internet karma. And actually, this content in the slide deck today is covered in a book I'm writing called Advanced Microservices. And this book will be available in about a couple months and is published through A-Press. So throughout this talk, we'll look at a few different use cases, beginner, intermediate, advanced, and how we can use Redis to solve our node problems. All right, so this first use case, our beginner use case, we're going to build a visitor counter, the kind you'd see on something like GeoCities. All right, and so here we have a simple, naive approach. On this approach, we create our web server. So this whole thing sits in a single file. Of course, we require the HTTP module. We declare a variable called counter, and then each time a request comes into our service, we increment that counter value, and we send it back to the client. And so I send that data back to the client as JSON. So I'm sending the counter value specifically. And I'm also sending the process ID. But you can basically ignore that for now. And so each time a request comes into our service, that's what those curl commands are doing. You can think of them as a user loading a page. So each time the user loads the page, they get data back in response. And so we see our counter is a 1, it's a 2, it's a 3, and everything's working great. It turns out the site that we just built, this user counter, is really popular. Everybody in the world is coming to the site and they want to see what visitor number they are. We need to scale this thing. And so here we take a really simple approach to scaling. We're going to grab the cluster module in Redis. And so what the cluster module does is when we execute a script, it will it'll execute it once and we'll set this cluster.isMaster value to a truthy value. And then so when we run, we're currently running in master mode, and we'll go ahead and we'll create 2 forks. And then so Node will then execute our script again in the background. And I believe it makes some child processes of the master process. And then so we now have 2 slave processes. So requests come into the master, and then they get round robined in between the slaves. And so of course, if you're using this kind of stuff in production, maybe you're using something like HA proxy or Nginx to do this round robining for you. But this approach is nice because it fits on a slide. So we see that when requests come through, the first user comes along, they make a request, they see that they're the first person to visit the site. But the second person comes along and they also see they're the first person on the site. The third person comes along, they're the second visitor. Obviously something broken is going on here. And that PID value that we're currently logging, we see that number hops back and forth. And so, this is doing, much like we might expect to happen under the hood, is that the user is going to the first slave, the user is going to the second slave, first slave, second slave. And so each one of these processes has their own counter variable, and that is why our number is incrementing erratically. I bet you're all wondering how to fix it. So let's learn about this thing called Redis and see how we can fix it. And so this is like a simple introduction to Redis. Of course, as RedisConf, you probably know a bit about Redis by 4 p.m. So at the heart of Redis, it's a key value store. Cool thing about it is that it has many different data structures, and we'll take a peek at those in a second. One thing I really like about Redis is that it has this philosophy where something doesn't exist, it won't error if you try to use it. So for example, if you try to increment a number, and which is, for example, if you increment a key which should represent a number, and the key does not exist, it will assume a sane default, 0, and then you'll get a 1 back. Or if you try to push an item into a list and that list does not exist, it'll assume an empty list and then return you a list with a single item. So this philosophy makes it really easy to work with Redis, especially in distributed environments where many processes may be trying to instantiate data at the same time. So Node itself is single-threaded, and then Redis is single-threaded. Of course, they, by single-threaded, I mean the sort of the source of truth. The main execution of these tools is single-threaded. Redis has some background ability to do some garbage collection. Node is doing some file system stuff outside of the main process, and then it waits until the I/O completes, and then it'll come back and it'll wake up your main thread. But at the heart, both these tools are single-threaded. Communication with Redis is really simple. Anyone here ever used Telnet before? All right, not too many. So Telnet is, of course, a way to send simple commands over the network over TCP. And so if we wanted to, we could actually issue we could send little text commands to Redis using this really simple tool and get data in response. Luckily for us, we don't have to do that. We have a nice REPL that we can work with. By default, authentication is disabled with Redis, which almost sounds scary, but it's actually fine, because also by default it only binds localhost, which means hackers aren't going to come in and break your stuff. That said, if you ever do listen for requests from the outside world, from the internet, you should authenticate it, or you will get bit by that. Another cool thing is that it has a lot of these caching features, and so you can set an expiration on a per key basis. You can also set a global expiration. We call it the LRU, the least recently used. So there's the ability to evict old keys if you run out of memory or if they're not used frequently. There's all sorts of ways to configure that. So to install Redis, it's super easy. If you're on a Mac, you can do brew install Redis. Linux, Ubuntu, Debian world, you can do apt-get install Redis. In most operating systems, there's a convenient way to get Redis running. And so I mentioned we have a REPL, and so here's an example of a REPL session. So we run Redis CLI, and by default, it connects to Redis on the local machine. We can issue simple commands. For example, we do a set with a key, in this case XYZ. We set the value to hello. We see, okay, it worked. We can do a get on that key. We get the string hello back. We can delete the key. We get a 1 back that says 1 item was deleted. And then if I get the item and it doesn't exist, I get a null. And then you can just quit to close the REPL. All right, earlier I mentioned the data structures, so here's a list of them. So the simplest data structure is a string. And so the string can hold really any sort of binary data. It can be, I think it can be as long as you want, as long as it fits in memory. You can put in numeric values and then increment and decrement them, which is a cool feature of strings. We also have lists, which is, under the hood, it's some sort of computer science linked list data type. And so, with a JavaScript array, we can perform push, pop, shift, and unshift. The list data structure in Redis will be similar. Well, they call them rpush, rpop, lpush, lpop. We even have rpush, lpop. Funny name commands. But essentially, it's the same data structure. We also have hashes. And so these are, it still exists under a single key, but the key will have multiple fields and value pairs within it. And so we can get and set properties, or the fields of this key. And so this is similar to a JavaScript object, or maybe even think of it as a JavaScript map. We also have sets, which contain unordered collections of unique strings. So you can add items, you can remove items. If you add an item 10 times, it'll only exist once. If you remove an item 10 times, it'll exist in there 0 times. And it behaves similar to the latest version of JavaScript. We have the set object. And so Node has sets and maps by default now. I always have sorted sets, which are a really cool data structure. And then so these items are, let's see, strings sorted by numeric scores. So it's kind of like a set and a list got together and had a baby, and that baby was called sorted sets. And so the values in this thing are unique, and we can query based on numeric ranges. And so we call those numbers the scores. They can be a floating point. We also have geolocation, which is kind of snuck that in there. Under the hood, geolocation values are stored as sorted sets. And so the data with geolocation, they contain a latitude, longitude, location, and then it's paired to a string. So for example, in an open table where I work, maybe we have tens of thousands of restaurants in our system. Each restaurant is located at a certain geo-coordinate, and then using geolocation, I can say that, hey, restaurant number 2048 is at this particular latitude and longitude. And then with geolocations, we can query based on distance. And so, if I see that, I'm a user standing here at the Marriott, what are all the restaurants within 12 kilometers? We can do stuff like that with geolocation. And then, just for completeness, I added PubSub, which isn't technically a data structure. It's a way to broadcast messages, and so clients can connect to Redis, and they can subscribe to different channels. And you subscribe to channels by name, and then you can publish to channels by name, and then any subscribers listening will receive messages. And then so using Redis with Node is pretty easy. If we're inside of our Node project, we do npm install Redis, which we can then require. And so in this case, I'm requiring Redis, and then I immediately create a client with that. When you create a client, you can specify, host and a port. You can also specify a callback, which will get fired when the connection fires. Notice, however, in this case, I don't actually provide a callback. I didn't provide a host and port either. It'll default to localhost. But specifically, I didn't provide a connection callback. And then so I immediately went willy-nilly issuing commands to Redis. And then you're probably wondering, how's that working? So philosophically, the way this library works is if, by default, when you make a connection, if you issue commands, they will get queued up. And then once the connection is established, it will then send those commands off to the server. And you can change that behavior when you instantiate the client. For example, maybe if you have a cache, and maybe if it takes a while to connect to the cache server, you could, for example, if you only use it for cache, you could have it fail any request. That way, you're able to go upstream to get the data much quicker. So in this case, I'm performing a set, redis.set, and so the Redis object gives us methods with the same name as the default Redis commands. So in this case, I'm doing a set, which is, of course, the set command. So we say, the hello key will contain the text world. The callback for this is simply, does it contain an error or not? Then I perform a get, and that'll give us an error or the data, and then we can print it off to the screen. And then we can do redis.quit, which will then close the connection and allow our simple process to die. So let's see how we can fix that visitor counter of ours. So in this case, we're still using the cluster module, still grabbing HTTP. We're now using Redis. So inside of our master, we're again creating the two forked slaves. And then so within the slaves, this time we're no longer instantiating that counter variable. Instead, we are simply, when a request comes in, we execute the redis.incr command. And so incr performs an increment of a numeric string piece of data. And then we get the value that's responded back to us. And then so we print out the value. So again, earlier I mentioned that Redis has this philosophy where if it doesn't create or it doesn't exist, we simply create it with the same value. And so that makes a lot of sense in this situation. So in an open table, we have, let me think, over like 100 different types of services. And then each service, maybe we're running 10 copies or 1 copy or a certain amount of copies of these things. And then so once it goes time to deploy an application, we execute this application. If we run 10 of them, you can imagine if inside this script I preceded this increment with a call to set the value to 0, you can imagine that these different processes would each be kind of fighting with each other to talk to Redis, each one of them setting the value to 0. And then perhaps one of the processes starts receiving requests. It's incrementing it to 1, 2, 3. Another process comes along, sets it to 0. That would be a disaster. But yeah, so this philosophy of Redis really helps us in this situation. So as we make our requests, we now see that our counter is always incrementing. We get a 1, we get a 2, we get a 3, and we see that our requests are bouncing back and forth between our two slave processes. And then we've just rebuilt GeoCities. Does anybody have a question so far? Great, cool. All right, now let's look at an intermediate use case. In this case, we're going to build a distributed job scheduler. All right, and so first thing we'll do is we'll take a look at another naive approach. And so in this case, we're going to be using some nested callbacks. I'm going to step through the code for us now. So, again, we grab our Redis module. In this case, everything we do is going to be a part of the same key, this jobs key. And then so this jobs will contain information about work that we want to execute in the future. And so the nature of this work is that we decide that a certain task is going to be executed at a certain time. So you can kind of think of this as being, for example, if we have a startup and we have like a sign-up form, and then people sign up for our service, and then we want to ask them in like a day, how it's going. In those fake, goofy emails you always get, it's like, here's the CEO of something Lee, and how are you enjoying our service? They send it to you. It seems to be like a day later and then a week later. Anybody get those? All right, a few of us. Anybody send those? All right, and so we're able to use this to schedule tasks. And so in this case, I'm just going to create really two simple tasks. I'm going to create one task which will be scheduled to happen 5 seconds in the future, and then another task which is scheduled to happen 10 seconds in the future. And so the commands I'm using, of course this all exists in a single file, but you can kind of imagine this being queued up asynchronously by a different service within our application. And so in this case, I'm doing the z add command. And so the z prefix, it's like a convention we use in Redis that says, this command is for sorted sets. And then so we do the add, which says, we're going to add an item to the sorted set. So the first argument is routing it to that jobs collection, that jobs key. The second argument is the time, so I take date.now gives me the time in milliseconds. I add 5,000, which is 5,000 milliseconds. Obviously, 5 seconds in the future, and then the nature of this work is that we're going to email user 1. And so you can imagine that being, perhaps that's like JSON, some sort of way to describe the type of work. So you could have like email this user or create this report, something like that. But here we're just using simple strings. And so we create these two tasks in the future. And then what we want this process to do is, since node processes are long-lived, we want to continually pull the Redis server for work to perform. And so each time we perform a poll, we get the current time, and then we perform two commands. The first one is z range by score, and the second one is z rem range by score. And then these scary sounding commands aren't too bad once you get to know them. Specifically what they do is they want to get a range of items from the sorted set based on score values. And so the first argument that we provide to that is, the beginning of time, 0, which in Unix world means, like 1970. So we say, hey, get every job from beginning of time to the current timestamp. And so, anything that would be scheduled to happen until now, we now have in our job list variable. So another thing we want to do is we want to make sure that this process performs the work, but another process doesn't. And so what we want to do now is delete those entries. And so that's what z rem range by score does. So the first one gets the jobs to perform. The second one deletes the jobs to perform. And then once we have that data, we can perform some work on it. In this case, we simply print them out to the console log. Unfortunately, we've now introduced a race condition with our code. So this right here is the output of a command called monitor. And so monitor is a great command for performing debugging. You wouldn't want to run this in prod, it'll slow everything down. But if you run it locally, against a local server that you're testing with, you can see the output of commands. And so what I've done here is I've added syntax highlighting. So each group represents commands executed by a different server. And so we can, we have one server, we can call it 20,000, another server 20,001, but just think of one as being the red server and one as being the green server. And so we can see that we have some information going on here. So the first chunk of information is the timestamp that the command executed. The next chunk of information, I believe, is the database number, the IP address, and then perhaps an ephemeral port for that connection, but I kind of lie and make it look like the PID. But anyway, the important information comes after that. And so so the stuff that comes after that is the command that we're executing, and then the arguments. And so we can see that when this fires, we see the red process gets the data, deletes the data. We can then see the green process gets data, deletes data. Again, the red process does the same thing. Unfortunately, once we get down to here, we see the two processes are now intermingling their commands. And so if we go back to the previous slide, we can imagine that first, if we have two processes running in parallel, the first one gets the z range by score command executed with Redis. The second one then issues the exact same command. Then the first one deletes the items. The second one deletes the items. And so what that means is that both processes now have the same list of work that needs to be performed. And then they both end up attempting to delete the same jobs. And so in that output below, that's the output of our two scripts running in parallel. So we see, the first process didn't get work, second didn't get work, first didn't get work. Then we see that both the first and second process got that same command to email the first user. So unfortunately, we've now sent two of these, canned emails from our CEO to a user, and they've gotten annoyed and deleted our service. Luckily, we can fix that. We have this command called multi available to us in Redis. And so multi allows us to specify that a bunch of commands about to be executed are related and that we don't want other clients issuing commands sort of in the middle. And so this allows us to execute atomic groups of commands. And so in this case, again, we're adding our work, instantiating the Redis connection. We're still doing that set interval to pull for work. But this time we're now using multi. And so the way we use multi is the Redis library for Node gives us this multi method. And then once you do that, it allows us to chain methods. And so we take that z range by score, the z rem range by score, and they're now chained. And so they're sent to Redis, but Redis isn't actually executing the commands yet. Once we perform the exec, it then has the server run all the commands together for us. And then so the monitor output for that looks a little different. We see we get the multi command, the two commands, and execute, multi, the two commands, execute. And then we've now eliminated the ability to have those race conditions. Anybody have questions so far? Perfect. All right, and then finally we'll look at a more advanced use case. This is something I use for a side project of mine. And so specifically we want to look up cities based on geolocation, grab information about them, and return it to the user. And so with this use case, we have a couple families of commands that we're going to look at, specifically the script and the eval set of commands. And so that multi command we used earlier was pretty convenient to perform these atomic operations, but it only really works in situations where the output from one command does not affect the input from another command, is really the simplest way to think about it. And then, so with the script command, we're able to actually sort of chain these commands together. And then so we can do this by actually writing Lua scripts, which are executed on the server. And so the first command we're going to look at is script load. And so what we do is inside of a client, we read some sort of Lua file from disk. We'd read it as a string. We would then pass it to the Redis server. So we do script load and then a string which represents that Lua script. And of course you need to do some escaping. Your new lines would be replaced with like a \n. But that is, for us with Node and the Redis library, that's handled for us. And then so once we execute that command, we get a SHA hash back to us. The same hash which powers get, for example. So that hash is applied to the script, and then the hash will represent the script. And then so from then on, we can perform the eval SHA command where we execute eval SHA and then that hash. And then this is a convenient way to refer to the scripts without having to send the entire script over and over and over again. Anybody here use SQL? Okay, about half of us. And so, with SQL, you can imagine, you're sending like select star from users where blah equals blah, and you send the command to the server over and over and over again. Maybe it's fine if it's a short query, but if your query is like a few kilobytes long, you want to use some sort of, perhaps like a stored procedure where you would keep that script, that query on the SQL server, and then sort of refer to it by name. And so that's exactly what eval SHA allows us to do. And so if we wanted, though, we could just use, there's another command called eval, where we would then pass it the entire script every single time. And now, hashing this script and then keeping track of the hash and then, constantly referring to it over and over and over again in our code could become tedious. Luckily for us, though, we have libraries to make this easier. The one I prefer to use is called Lured, and we'll take a look on the next slide on how that's used. An interesting thing with these commands, these eval commands, is that we need to specify to Redis the name of all the affected keys ahead of time. And so we do that in a declarative way. As we execute our script, we pass the keys into it. That way, Redis is able to look at those keys, make a decision ahead of time before it executes the server, before it executes the script. That way, if you're in like a Redis cluster situation, it knows which servers to execute your code on, for example. And so, like, while you could, for example, sneak the keys into the body of the Lua script, that would be a no-no if you ever actually want to be able to scale this. And so this code example here, this is our Lua file. And so this is called get cities.lua. And then the purpose of this file is to find all cities within 10 kilometers of a specified query. And so the first thing we do is we grab the keys that are passed into our script. And so we have a key which will represent geolocation data. And we also have a key which will represent a hash of city data. And then so we grab that from the keys global that's provided to us. One thing you're probably noticing that these, we're starting these numbers with 1 instead of 0. Fun thing about Lua is it's actually a 1-based language, which feels a little different if you're coming from JavaScript, or I guess most modern languages. So we also grab programmatic arguments. And so, for example, with this script, we want the ability to get the longitude and latitude of the request. And so we're grabbing those from the argument, the argv global, and then we're just assigning them to local variables. And so, whereas in JavaScript you'd use var, const, or let to define variables, in Redis, within Redis, we're using local. Otherwise, actually, the syntax is really similar. This could almost be valid JavaScript. And so, now that we've grabbed this data that's passed into the script, we actually want to call a Redis command. And so we do redis.call. So Redis is like a Lua table, I guess it's called, with a call method on it that we can use to execute commands against Redis. And so in this case, we're going to perform the georadius command. And so what this will do is it'll go to our key which contains the geolocation information. We pass in the longitude and the latitude. We also pass in a radius, which in this case is 10, and then kilometers. And so you can specify different units if you'd like as well. And then so what this does is Redis then finds all the items within that radius and then returns it to us in an array. And then so that city IDs variable now represents an array of the IDs of our cities. And now that we have that cities ID, we want to actually get the different cities from a hash. And so in this case, we have our that key hash, which contains information about our cities. And so you can imagine the fields would be like an identifier of a city, for example, like maybe San Francisco or Oakland, or more realistically, you'd be using numbers like 1 or 2, whatever your primary key is to represent that data within your organization. And then so the HMGet, that stands for hash multi-get. And so we're saying, hey, let's get multiple items from the single hash, and then here are the identifiers. And then so we, of course, pass in the key that we want to work with, and then we pass in a list of the identifiers. And so this unpack function, I believe it works essentially the same way as bind and apply would in JavaScript, where you take an array of items and then you sort of apply them against the function as if they're arguments. And so normally the HMGet takes different arguments for each identifier that you want to get back. And so this unpack takes that array and then turns them into these arguments. And then so once we get that data, we finally return it from our Lua script. And then so that gets returned to the client to work with that data. All right, and then so this screen has a lot going on, and I'll try to explain it line by line. And so again, we're instantiating a Redis collection. This time we're also grabbing the file system module, and we'll see why in a second. We specify the 2 keys, and so these contain the geolocation information as well as a hash, and these contain information about our cities. I also create this object called Lua, and then so this is an object of objects. And then this sort of describes our library of Lua scripts that we want to use in our application. And so on this side project of mine, I have like maybe five scripts going on for performing various types of work. But in this case, we simply have a single item, and that is called find. And so within this nested object, we have an object which contains this property just called script. But later, this object will get mutated, and we'll see how it is mutated. And so in this case, the script will simply contain a string which represents the Lua file that we want to send to the server. And since we're probably reading these scripts from disk early in the bootstrapping process of our application starting, it is fine to read the file synchronously from disk. Much like those require commands are synchronously blocking as they read the file from disk, our code which reads the Lua scripts does the same. And finally, I'm going to require that Luard library that I mentioned earlier, and I'm going to perform a create. And then so we do a little bit of dependency injection. We pass in our Redis client. We pass in this Lua global as well. Now I'm going to actually create some data. This data probably already exists in our database, but it illustrates our example. So in this case, I'm going to add an item to our geolocation database, which will contain the longitude and latitude of San Francisco. And then for the identifier, I'm just going to use San-Francisco, just to make it easier to follow along. And then I'm also going to add an item to our hash. And so this hash contains our city information. In this case, I'm JSON stringifying some data, some information about that city. And so it's the name San Francisco and the current temperature. And then we do the same thing again with Oakland. It's a little warmer in Oakland. The geolocation is, of course, east of here. And so we now have 2 keys in Redis with 2 pieces of data in each key. And then I go ahead and define our Berkeley object, which contains the longitude and latitude of Berkeley. Now we perform our luard.load command. And so what this does is Luard will take those scripts, sends each one of them off to the Redis server, Redis hashes them, and then returns the hashes for each one. We mutate that Lua object, like I mentioned earlier, and then so find now contains a property called SHA, which is the SHA of the script. Cool, so now once that's done, we're going to actually execute eval SHA. And so we see that we're performing redis.eval SHA. We pass in the hash for our find command. Then we pass in the number 2, which seems a little out of place. And so earlier I mentioned we need a way to sort of declaratively tell the Lua scripts that, hey, modify these keys, and then also, hey, here's some data, some arguments that's passed into our script. And so that's exactly what that 2 does. The 2 says the next 2 arguments are keys to look at. Everything after that will then be arguments, and then of course, this being node, finally we have the callback. So the script takes the geolocation key, the hash, the longitude, latitude, executes it on our server, and then finds our data. And then once that's done, we get our response back, which would be an array of all matching items from a hash. In this case, we only have Oakland, and then so we print out Oakland and the temperature to our console. Does anybody have any questions yet? All right, cool. So in conclusion, Redis offers a bunch of cool data structures. Personally, I love it. I'm pretty bad at like the low-level computer science stuff, but to know that I can shove data into this geolocation, for example, and then query it super fast, feels really nice. And so with OpenTable, for example, we're putting hundreds of thousands of restaurants into, or however many restaurants we have, into this object. I think it's in the order of 100,000. And then we're able to query it very quickly. And so I can say, hey, here's the center of San Francisco. I'm standing at this corner. Get me all the things within 10 kilometers, and maybe it's coming back with thousands of restaurants. And it's able to do that within usually like less than 10 milliseconds. And then this is just running on my my local machine. Redis is really useful for keeping state synchronized across multiple node processes. So you can kind of think anytime you're doing work with sessions or anytime you want to retain state. My background is in PHP, where each time a PHP script runs, it lives for like tens of milliseconds or 100 milliseconds, hits the database, gets some data, and then it dies. But with Node, we're able to run much longer. We're able to create like those globals like we saw on the first slide, that counter. We're able to mutate those globals, and it gets kind of easy to take these little shortcuts with programming. But once you actually want to keep state maintained across multiple processes, that's where a tool like Redis really comes in handy. We can use the multi and exec commands for performing atomic operations, where the two commands are essentially independent from each other, in that the input and output don't affect each other. Or we can use the script and eval family of commands for performing these chainable operations, where we want to actually execute code on Redis. We want to perform much more intricate operations. Cool. That's the talk. Thanks.